All right, let's solve some examination problems from the MSBTE paper on mean deviation. We have just learned the concepts of what is mean deviation. Let's solve some problems. And a quick reminder, the overall statistics weightage is going to be for 16 marks minimum. And we are talking about type 2. There are only three types of problems. We have covered type 1 in detail. Type 2, the mean part we have covered in the beginning episodes, and we are just going to cover the second part, which is mean deviation, in this episode, and that should complete the whole type 2 problems. And type 3 will be the future videos that we'll be talking about. So the mean deviation itself normally comes for 3 to 4 marks as a weightage, and the mean part, again, this again is going to be for 3 to 4 marks. So put together, the type 2 will be roughly for 8 marks. So that means, like, out of the 16 marks minimum that you might get from the weightage here, roughly 8 marks would be coming from a combination of mean and mean deviation. So that means it's almost 50% weightage for mean and mean deviation for the type 2 problems as a whole. So just keep that in mind, so that you cover both the aspects, and it's very easy. Like, once you understand mean, a lot of concepts are for mean deviation would be easier to calculate. Okay. And in terms of just the mean deviation, the purpose of this particular episode, it has come only twice in the last 4 years. We did not have any question in 2019. We had one in summer 2019. We did not have in winter 2019. We had one in summer 2019, and we had one in summer 2018, I think. So none in winter 2018 also. So we'll just talk about these two problems. And interestingly enough, this is this part of the problem. There are two questions, sub questions here. This is the mean deviation from the mean. This is how they'll word it in the exam. Find the mean deviation from the mean. That means just it's simple mean deviation, not to get confused. And this problem, if you see, it's group data, because we have class intervals and we have kind of a number which is kind of in a range 0 to 10 and stuff like that. And I've explained group data many times in the past videos. Just check out that. Even in the mean, when we calculate the first part of this type 2, just the mean, I've explained that. So by this time you should know what is a group data. And there's the second question, the second time it has come in summer 2018, it is all about ungroup data, and this is pretty simple. And this is the exact example I took when I was trying to explain the concepts of mean deviation, and I had taken a live example and solved it, and this was a very example I had taken. So that should be a good recap, and I had put a lot of good visuals to explain that. So in case you want to do a good recap on this very problem, you can just go through the previous episode where I was talking about the mean deviation, and then go through that video and you'll see that this example has been explained in detail. But in this case, I'll just explain it in a nutshell from an exam standpoint of view. That should be sufficient. So I'll spend less time on this ungrouped data over here, and I will on this problem, because this has been already covered, and I'll try to spend disproportionately more time on this group data. Both are like very easy, but let's get started. So let's take this problem first, the ungrouped data, and solve it. Okay. So what do we have here? We have a summer 2018 problem for 4 marks, and we have got ungrouped data. Okay, that's just the raw data, and they're asking us to find the mean deviation about the mean, which is nothing but mean. So we will call it MD, which is mean deviation, or we can call mean absolute deviation. It's all the same thing. And the biggest trick is, before you solve, from the very question, you should understand that, okay, the given data is ungrouped. That's your first check mark. And like I've explained in the conceptual video of mean deviation, always create a table and populate the values one column at a time. That way it's very easy, and you can see it holistically what's happening throughout without doing any mistake. That's the best way to do that. Okay, so now let's get started. So what I'm going to do is I'm going to take the values that are given, and I'm going to put that in the first column. Okay, so this is the column I'm putting that. Okay, this is what I'm putting. So although they are not talking about any distance or something, they have just given the values. You can think in your mind either it could be a distance or marks or stuff like that. And since I've copied and pasted this from the previous episode, you will see the word distance, but don't get confused. It does not really matter what they give. All they're giving is a raw data. So the first column, you put all the raw data, which is denoted by X, 3, 6, 5, 7, 10, 12, 15. That's what you see here. So this is what we'll call as X. And if you count this, how many values we have? 1, 2, 3, 4, 5, 6, 7, 8. So total number of observations, n is equal to 8, or frequency is kind of 8. And that's what I put here, the number of observations. over n is equal to 8, and I've listed down the first value is 3, the second is 6, the third is 5, and so on and so forth. And the very first step that we do is for finding the mean deviation about the mean. The first thing that we need to do is just find the regular mean, just find the regular arithmetic mean, and from there we will devise the next thing. So that's a step number 1. So finding the arithmetic mean over here, right? And what I've done is I've also copied and pasted these steps here for ease of reference. You don't have to write this in the exam, just for reference, but I'm just trying to number this 1, 2, 3, 4, 5, and I've kind of tagged those numbers over here. If you see all the steps, I put it here so that you have a reference how to do that. So put your values in the table, create a table, start building one column at a time. The very first thing is whatever is given, put that in a column, which is what we did here. Okay, and here now we are going to calculate the mean. And how do we calculate the mean? We are just going to add up all these values over here and divide by 8, because that's the number of observations. That's what I've done here. So the arithmetic mean, which can be represented as x bar or mu, whatever you want to call. Normally textbooks use x bar, so let's stick to x bar. So you're going to add up all the values in the numerator and divide it by 8. So if you add up all the values in the numerator, you're going to get a value of 76. The denominator is going to be 8. So 76 by 8 is 9.5. So the average mean, the arithmetic mean, not the deviation, just the mean, the mu or the x bar is 9.5. That's what we get here. So what you can do is normally I've also put that in the column. You don't have to put that, but it helps when you do the next steps. So I've just plotted that here. So step 1 is done. I've calculated the arithmetic mean, the mu or the x bar, whatever you want to call, and I've just written the same value all over the place, 9.5, 9.5 repeatedly, because I'm going to do the subtraction in the next column. That's the reason I kept it. So if you see here, this 9.5, I've just taken and I've copied for all the 8 observations against this column. So I've created the step 1, another column I have added. Okay. The next thing is we're talking about mean deviation. For that, we need to calculate the first we need to calculate the individual deviation. What does it mean? We need to understand how far is this value from this value. How far is this value from this value? That means we need to take the difference of that. And so how do we do that? We take the given values in the given problem, which is denoted by x, minus the mu value or the x bar, or whatever you want to do it. We can do it this way also. So we take the difference between the two values. We'll do x minus the x bar, the mean. Okay. So that means it's going to be 3 minus 9.5, which will be minus 6.5. Here it will be 6 minus 9.5. It will be minus 3.5. And that's how we kind of calculate all the values. And that's your step 2. Okay, that step 2 is complete. And if you see here, that's what your step 2 is. Calculate all the individual deviations, the difference of each of the given number from the mean, which we got in step 1. That's what we done. So we have completed with step 1, we have completed with step 2. Now the step 3 is, like I discussed, we don't want to have negative values, because when we add up those numbers, it becomes 0. So we're just going to take the absolute values, we're just going to make them all of them positive. Okay, that's your third step. So in the third step, if you see here, I put the absolute symbol in red color, this one, and I'm going to take each of this value and just get the absolute values in the next column. So I'm dropping the negative sign and taking only the positive sign, because if I add up all of this, which is what I want to do, to eventually it will be ending up into 0, and that's why I don't want it. So one way to do that is get rid of the negative values by only considering the magnitude, the absolute positive value or the absolute value, and that's what I get here in step 3. Just get the absolute or positive value of the distance, and all of this I get in pure positive value. Okay, that's your step 3. Step 4 and step 5 are combined over here. So what we need to do is, since we are finding mean absolute deviation, what is the overall absolute deviation, mean absolute deviation? What is the average of all of them? So we have to add up all the individual deviations and then divide it by the number of observations, which is 8, which is the combination of step 4 and step 5. We add up all the absolute values from the step 3, and then we divide it we divide the value in step y based on number of values given in the problem, which is n is equal to 8, which is the frequency. That's what we do. So if we take the last column over here, what I've done is, if you see this sigma sign, that is nothing but adding up. So I'm going to add up all of this number, whatever I'm highlighting here. If you see, if I add up all of this right from 6.5 all the way through 8.5, the number is going to be 34. So I'm going to add up, that's what this sigma says. So this particular value is nothing but summation of x minus mu or x minus x bar, that's what is 34, and that's the numerator for the next column. Okay, so I'm taking the 34 here and dividing it by 8, which is the number of observations that I've got initially. That will stay as it is, and then whatever answer I get in green, 4.25, that's your final answer, which is nothing but, either you can call it as mean deviation or absolute mean deviation, or mean deviation from the mean, like they have asked in the exam. And I also written down the same answer over here. If you see here, I've just put the formula which I just explained, and I've written the numbers individually as a step. This step you need to put in the exam to get the marks, so make sure this step is important. And then you get 34 by 8, 4.25 is the final answer, like just how I put over here. That's what it is. So that's how you need to calculate the mean deviation about the mean for ungrouped data. Now let's quickly jump and spend more minutes on the group data, the second type of problem that we get here. So if you see here, again we have the problem states, find the mean deviation from the mean, and this time it's a group data. So nothing changes, just a minus couple of steps we need to do, otherwise the overall process is still the same. And like I said before, solving, hints and tricks, always understand the problem, what they're asking. So we have clearly noticed that it's not an ungrouped data and it's a group data. So we have got that. They have got overlapping boundaries. That means you see it's this interval ends at 10, this interval starts at 10. This interval ends at 20, this starts at 20. So there is a continuity here, that's called as an overlapping boundaries. The boundaries overlap, and hence we will use the midpoint formula. You need to recap what I explained in the first episode for calculating mean for group data using midpoint formula. So we have to apply the midpoint formula. And like as always I said, always create a table and populate one column at a time. That way it's easier. And the same steps are applying here also. We'll just have a couple of more steps because we need to apply the midpoint formula. So what is the first thing that I'm going to do? Whatever is given in the data. So we have got class, interval, and the frequency. So assume that in your head, this is the number of students. Like I said, always give some examples what they're talking about. There's a number of students here. Okay, and here it's the marks. Okay, so that way you know how to think about it. Otherwise, if it's very abstract, it's very hard to apply, and sometimes you might forget. Always create some analogy, marks of students, or height, or weight, or something of that sort. Okay, or distance, or whatever that is. So over here we have got number of students at the bottom, and we have got the class intervals are the marks by the students. Okay, and what does it mean? 5 students have got marks between 0 to 10. We don't know how much marks they exactly got, but it could be anything between 0 to 10. And what we will do is, for the sake of benefit, we'll get the average of this as a midpoint. So 0 to 10, the midpoint is 5. And we'll assume that all the 5 students got exactly on an average 5 marks. That's how we're going to assume the midpoint. That's what we're going to do here. So the first step is, whatever is given, the class interval and the frequency, put that in a column in a table. That's what I've done here. I've taken the class interval and I've taken the frequency. I'm calling it as F. Okay, and normally you can write small f, not big F. Okay, the next step is, since I want to find the midpoint of these numbers, if you see these numbers, I want to find the midpoint. So I'm just going to take a midpoint formula, and whatever is the number in between, I'm going to calculate that. Between 0 to 10, 5 is the midpoint. Between 10 to 20, 15 is the midpoint. Over here 25 is the midpoint. Over here 35 is the midpoint. Over here 45 is the midpoint. That's what I get. And how do I read that? Now I know that 5 students on an average have got 5 marks. That's what I'm assuming. Over here I'm assuming 8 students on an average has got 15 marks. That's what I'm assuming. Over here I'm assuming 15 students have on an average got 25 marks. That's what I'm assuming. So that means if every student has got 5 marks in this interval, there are 5 students. So I need to multiply these 2 columns to get the total marks for this class interval for all the 5 students. So 5 into 5 is 25. Similarly, I'm going to multiply here, 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 and here, which means that I'm going to multiply f into x. So this is the f part, this is the x part. So I'm going to multiply all these things so that I get the total marks for all the students belonging to the class interval. And then what I do is, since I need to take the normal mean, I'm going to add up all these things. So let me just get rid of this. Hold on. So if you see the fx column, this thing, I'm going to add up. I'm going to add this 25 plus 120, this thing, this whole piece I'm going to add up. So that's what I'm putting a symbol here, sigma, that is summation of f into x, the whole column. And that's going to give me a value of 1350. So now, like I said, the first step is calculate the normal arithmetic mean. And now since using the midpoint, we have done that. This is what you would have done if you have been calculating mean for the normal problem until this point, which will be the step 1, right? So the arithmetic mean, the normal mean is going to be this summation 1350 divided by the summation of all the frequency. This is 50, which is what I put here. If you see 1350 divided by 50 is equal to 27. And as a habit, I'm writing this 27 in all the, adding a column and writing all these values over here so that I can subtract it. So let me get rid of this thing so that I can make sure that it's visible. Okay. So now I have the arithmetic mean for the whole class. And what does it mean? We can assume, regardless of how many marks the individuals have got, we can safely assume on an average, each student of this whole class, of the class of 50, every student we can assume on an average has got 27 marks. That's what it means. Okay, that's your step 1 we have done. The step 2 is now we need to calculate the individual deviations. So what do the individual deviations mean? Now we know that on an average, every student we have assumed has got 27 marks. So how far the marks are from this average? Okay, so what does it mean? We need to calculate this value. These are the marks, the midpoint marks that we have calculated, and we need to see what is the distance between this and this. We need to calculate the distance. Similarly, what is the distance between 15 and 27? So how far are the marks, the midpoint marks that we have got, how far on an average they are from the medium, from the mean, sorry, not median, from the mean. So we need to calculate the difference, which is what we kind of get here, x into x minus x bar. That's what we are getting here, right? So if you see here, 5 minus 27 is minus 22, 15 minus 27 is minus 12, this minus this is minus 2, this minus this is plus 8, and 45 minus 27 is 18. That's how we have got in x and x minus x bar, that is the individual deviations. That's step number 2. In step number 3, we know that we don't want any negative values. We have seen that before. And step number 3 is just taking the absolute part for the individual deviations, and we just put the absolute symbol here, x minus x bar, and we just convert every negative value into positive, and positive remains as it is. That's what we do. That's your step number 3. Step number 4 is what we need is now, these are the individual deviations. We, as a whole, we want what is the overall average mean deviation on an average for the class as a whole. That means we have to again add this up and then divide it by the frequency, which is 50. But before doing that, one important step is, since these are the marks for the individual, right? This is the deviation, this is the individual deviation. And since it's the group data, we should not forget the frequency. And that's the most important step. This is the most important step, because you might tend to forget and you'll start adding up here. It's group data. And since it is for a single student, we have to multiply the number of students, which is the frequency over here. Let me take a different color and show you. So if you see this frequency, we have to multiply this frequency with this one, each of this one, to get the individual deviations for all the students in that class interval. So that's what it means. So 5 into 22 is 110. That's what I've written here. So whatever is the absolute value we are getting, we have to multiply by the frequency, because this is for individual student. And since we have more students in the class interval, we need to multiply that, and that's how we get that. And once we get this step 4, what we do is the step 5 is the easiest piece. Now we have almost completed the exercise. So we need to add all of this, because we need to find the overall mean deviation, the average mean deviation from the mean, about the mean, right? So now we have got this individual deviation. So we need to add this all up from all this point, if you see, and the value is 472. And now since we want the average, we need to divide this by the total number of observations of frequency, which is 50. So we'll have to do 472 by 50, and that's what we kind of do here. So the MAD is nothing but mean absolute deviation or mean deviation about the mean, whatever you want to call it, there are a lot of different names. And that's the final step where you take the numerator as this particular summation, what we got here, and divide it by 50, and the final answer is going to be 9.44. That's highlighted in green. So this is the final answer, and that's how you kind of secure your marks. And I also have written down the formulas here for the mean of the group data. If you remember from the first episode, I've copied the formula. We have to take the interval midpoint and you have to multiply by the frequency, which is what we did here in this f into x, right? That's what we kind of did here. And I've put the detailed steps here where we are multiplying the value, and we got this value as 27 over here, which is what we got here, 27. Okay, that's the first step. And then we populated the table, and for the mean deviation from mean, we applied this last column where we took the overall summation and divided the frequency. So in both the cases, the denominator always remains the same, the frequency, right? So the denominator always remains the same, so you don't have to get confused. Okay, only the numerator changes, and the final answer we get is 9.44. So on an average, if you think this has the marks of the class, on an average, every student is roughly 9.44 marks away from the mean, which is 27. So every student is roughly 9.44 marks away from the mean, either this side or the other side. That's what it kind of means. So that's how you solve the mean deviation problems for group data. And the closing comment is, it's very simple. Just check if the data is group, ungrouped or group. And if it's group, just use the midpoint formula and the remaining steps remains the same. With that, that's going to be a wrap up on sealing your 3 or 4 marks on this type of problems on type 2. And we have done with type 2 problems. So we have done with type 1 already. Now we are done with type 2. Now next we are going to attack type 3. And I'll see you in the next episodes when I talk about type 3.